Hello, everyone, and welcome to this episode, I guess, of the Astronomy Cast Office Hours. Not Astronomy Cast, CosmoQuest Office Hours. It's been a long day. I am tonight's question answerer, planet destroyer, world destroyer, whatever you wish to call me. I'm Dr. Pamela Gay, and I'm going to say hello to everyone in the chat. Hello, Paranor. Hello, Fenmil. I am looking for a window where I can get all of your names at once. I have an additional new monitor. This is going to lead to so much confusion. Um, there's a list of you somewhere here. I want to say hellos. Hello, Paranor. Hello, Bill Wink. Hello, Bortex. Hello, Fenmil. Hello, Herlayu. I don't know if I said your name right. Herlayu? Hello, Lucid Schizophrenic. Hello, Lynxwort. Hello, Michael Meyer. Hello, Rock It Sage. Hello, Slow Cool. Hello, Starstrider Stalker. Your name still creeps me out a little bit. Hello, Thrain Maru. And hello, Zine? I don't know if that's how you say your name. I don't see Cosmic Lettuce on this list. It probably just needs to be refreshed. So, welcome, all of you. So, my plan for this evening is to answer any questions within reason that you answer me related to science. And while I'm doing that, I'm going to work on destroying worlds, or at least one world in an animation where I'm looking to depict as accurately as I can exactly how planets that get too close to their stars have a rather horrible life. Now, if I'm looking all over the place, it's because I just realized I completely forgot to set up processing ahead of time. She will be called Ozymandias. Okay. Uh, so, um, you guys are awesome. So for those of you who've been around a few weeks, you are awesome. Thank you so much. We are working to figure out how to build our audience. Hey, Noel. Hello, Cosmic Lettuce. Um, we're working to figure out how to build our audience. And if you guys can give a shout out where appropriate, like don't go invade someone's feed and say, "Hey, all of you, come listen to Starstrider." That's rude. That's bad. Don't do that. But if you can tell people who aren't already watching something that this is here, like tweet it and things like that, it would be absolutely awesome. Now, I'm going to switch over to my programming screen, and it currently shows a giant black box because I just realized it's coded to. That's hilarious, Paranar. It is coded to show you a screen capture of a screen that is no longer here. So I have to redo the screen capture. This will take me just a second. Well, it'll probably take me a little longer than that. Yeah, it wants to do the wrong screen entirely. So while I am cropping the screen, go ahead, ask me questions, whatever it is that you'd like to do. I am here. Rocket Sage, you are allowed to lurk all you want. I have spent much of my life lurking and not logging in so that I could learn things without people realizing I was sitting there learning from everything they did. This is how we learn things. We lurk, we listen, we watch. I have papers to work on. I have many things to work on. How did you enjoy being in two places? Oh man, today my schedule got entirely away from me. I managed to completely. Thank you for the thing that went chimey chime. Thank you, Rocket Sage, for hosting me. That's awesome. So yeah, earlier today I was reviewing my calendar and I had this realization that something that I totally thought was later in the day wasn't. Basically, I forgot where California is and did my time zone corrections entirely wrong. So that did not go as planned as you might imagine, but we figured it out as we went. And now I'm just. Uh, oh, going the wrong direction and trying to crop something. Strangely, if you make something smaller and smaller, it gets smaller. I will have you a new window in just a moment. I'm almost there. I'm so close. That was the wrong direction again. That was the correct direction. So feel free to ask me questions. So Bill Wink is saying, okay, it's about mapping, my favorite. How does one determine what camera is being used with the Mars mapping? Okay, so I can tell you it's either CRX or high rise, and you can tell from the name, the two of them have different name codes. So if you go in and check out naming schema, you can figure it out. The only problem I have, Fenmill, with Chasing New Horizons is they make such an argument about Pluto that I'm a bit worried that poor Michael Brown is going to get hate mail. And I like Michael Brown, and I'd rather he didn't get hate mail. So, okay, we have found my windows. I'm going to figure out how to make my text bigger because, wow, that's tiny. It does not want to make my text bigger. Okay, so let's go to help. Increase. Nope, that wasn't it. I'm starting to understand why I did what I did last time, which was just zoom in really close. I don't want to create a font. Hello, all of you. So, you know, you either have to make Pluto, Ceres, and Sedna and a whole bunch of different objects planets, or you have to make none of them planets. Yeah. I, Paranor, have gone many weeks without having to resize anything. Dear Automod, you have life issues. Okay, so let's figure out how to change my environment. Nope. Okay, I'm just going to do exactly what I did last time, and I'm going to zoom in on these. And the way I'm going to do it is I'm going to put them down in the bottom of the screen, side by side, and embiggen them. Again, you guys are welcome to ask me questions while I'm doing this. I actually now have your chat in a place where it's super easy for me to follow chat while doing everything else. So the first thing I'm going to do is chop off the top. Let's see, how's that doing? So I have, let's chop off more of the top. Now, let's embiggen. Let's chop off more of the top. Okay, do I now have something you guys can see, or do I need to zoom in further? Because I can totally zoom in further. I would have to look that up, Bill. I don't know which one that is without zooming in. I mean, without doing some Googling. Okay, Noel, enjoy your day. You can always just leave this on in the background and check in at what's appearing on the screen. This isn't Python. This is actually processing, which is a it's kind of a framework built around Java. To answer your question, Bill, the key is the PSP part. What I don't know is if PSP is a CRX or a high-rise image. I'd have to look that up. Okay. Oh, Noel, I'm sorry that you won't be doing the same thing, but you're giving me a chance to catch up with what you're doing. Alrighty. So what we have right now is an extraordinarily hot star. The shade of blue actually matches the color of this temperature of a black body. We've gotten the limb darkening going to show how the edges of a planet are not a planet, of a star, are a little bit darker because you're looking through more atmosphere. And then I have a greatly embiggened planet next to it. And what I'm working on figuring out how to do is to do a gradient in the color that allows me to basically show how trying to figure out the right way to put this, to basically show how the part of the planet that is closest to the star is significantly hotter. Again, using the black body here, it gets heated up towards white because our eyes don't perceive green, and then cools off towards the other side of the star. Now, what I did first was just an initial approximation. So what I'm going to do now is try and take my initial approximation and play with it a little bit to try and get the shading on the planet to change shape as it goes. So the way I'm going to do this is, instead of drawing half arcs like I'm doing right now, I'm actually going to draw ellipses that change in different ways in value. And by drawing them overlapping, I'm hoping that I can get something that is pleasing, but it's inevitably going to take me multiple tries to figure out how to do this in a way that doesn't have all sorts of weird shading issues. Wait, why did I just get tagged? How do you say? Oh, yeah, you just at me. So, yeah, Linkswart, what's your question? If you can just at me, it highlights the question and I see it with my peripheral vision and know to stop and look at the chat. Okay, so let's try my initial plan, which is to not change the position in the y-axis and see what happens. That's awesome, Bill. That's super cool. Can you drop that to me in an email? Because I will never find it in the chat ever again. Wow, I drew something horrible. Okay, let's also not subtract n. Okay, let's try this again. Typos occurred. Got it. Got it on the first try. I am happy. Okay, do you all see how it's shaded brightly? Why are we getting sage height? What did I miss over on Streamlabs? Oh, thank you for the host, Rocket Sage. Rock It Sage. I am super pleased with that. Now what I'm going to try and do is reduce it on the other side to be darker. So there's side one. Oh no. Yeah, I don't know how you would do this, but I'm enjoying doing it. Okay. So, shading of the planet. Here I'm going to do I don't know why. Oh, I know why I had to print N. This is bright side. Just a friendly reminder, you add comments to show that you love yourself, or at least that you love your future self, even if you don't love yourself right now, because uncommented code will cause you to hate yourself later and is a sign that you hate your future self. Okay, so I'm going to copy this and just adjust it for the dark side. There's a light side, there's a dark side, to the force, to the duct tape, to the planet. And this will be a tidally locked planet. So at some point we're going to have to figure out how to math to change this shading that I'm working on figuring out. Okay, so for this one, let's change our comments over to dark side. Why do you want ice cream, Paranor? Now I want ice cream too. Do you not like me? You probably do like me, but I'm attached to a microphone, so I can't go get ice cream. Okay, so there's my starting color. Now, what I did here was I got brighter. What I'm going to do next is I'm going to pull up an HTML hex codes black body. There is a fill plate article that I found last time, and I'm trying to find it again. Star colors. Thank you, Uncle Bill, for the host. A hex on stars. I found it. And I'm going to add this link to my comments, again, because I like myself. So here are our normal everyday black body temperatures. I'm just going to stick this up at the top. If I can figure out where Welcome, everybody! I'm not quite sure where you all just came from, but you have stumbled into the destruction of a star. You came in from Horizon Psi. Welcome, all of you astronomy lovers. I am Dr. Pamela Gay. I am in the process of doing a data visualization of a hey now thanks for the follow, thanks Hogva, and thanks Dark Crusader for the follow. I am in the process of coding up how you destroy a hot Jupiter as it orbits around a star. Thank you, Horizon Psi. Thank you so much. Okay, Vortex question is escaping. You just read a post on space.com that a black hole is consuming a mass equivalent to Earth's sun every 2 days. So this is actually the fastest eating black hole we have so far found. Now, to be fair, this is not a normal black hole. This is a supermassive black hole that lurks down in the center of a large galaxy. This galaxy recently had something happen to it that caused a lot of the dust and gas in the system to start getting collapsed down towards the center. So there was either a collision or a shock or something happened, and all the dust and gas went, "We're going towards the center." And the black hole went, oh, thank you. My gravity shall help you. And as the gas and dust fell in towards the center of this galaxy, it didn't fall straight in. It sort of spiraled in, and as it spiraled in, it ended up forming a disk of material around the supermassive black hole. And this disk is thick, and it is full, and material in it is frictionally getting slowed down. So as particles go past each other, they get slowed down through transfer of energy, going to heat and things like that, which is why this sucker is glowing as hot as it does. The reason that we see quasars is because of all that gas and dust down in the center glowing. In some cases, it gets hot enough that the insides of an accretion disk have nuclear reactions just like the inside of a star. And then that material is actually funneling in to the black hole itself. And it is from looking at the velocities in the accretion disk, the brightness of the accretion disk, calculating the mass of the central black hole, and running through a whole bunch of simulations that they figured out this super massive black hole in the center of a active galaxy that we call a quasar. We mathed that it is eating 2 solar masses, 2 times the mass of our sun. It is eating 1 times the mass of our sun every 2 days. So yeah, our sun, if it were squished out into dust and gas and distributed through this accretion disk, would get eaten in 2 days, which is kind of cool. Is there another question in there? So if you at me, I can find questions. So to go back to explaining what I'm doing, I'm using software called processing, and a actual listing of the HTML color codes for black bodies. So stars, planets, warm things, hamburgers, they emit light in a continuum of color. It's not symmetric. There's going to be more light given off on the blue, a long tail of light given off in the red. And each black body curve is distinct to an object having a very specific color. So we can look at any star in the sky and get at what its temperature is reasonably, strictly by Linkswort. Go ahead and repost your question. Thanks everyone for the follows. So I'm looking up actual temperatures of different stars. And in this case, I have a planet. I'm modeling the hottest planet we know about. That this planet is so close to its star that its outer level, its outer atmosphere, is the color of a star. The inside, it's cooler. So this is kind of awesome. Hello, Denizen Earth. Welcome. You guys are all awesome. So, Noel, I can't read your code, but do I understand correctly that you made the gradient on the planet scaled on each row of pictures as a function of horizontal width in pixels? Yes, that is exactly what I did. And yeah, Linkswort, re-ask. Hello, Art is Passion. Okay, so what I've done so far is, here's my star. I made my planet huge. My planet is no longer to scale because I wanted to be able to see what I was doing a little bit better. Hello, Neuropilot. So what I'm now going to do is I'm going to try and shade the dark side. Thank you for the follow, Ricky Dimaidu. I'm going to work on making the other side of the planet nice and a cooler temperature. So the temperature I'm going to use is the temperature of a K4 star. So I'm going to come down here. And so my starting color is the center color. I'm now going to type in, okay, apparently my starting color, I'm very confused. Am I being colorblind? I may be. Let's go with a darker color. Let's go with the color of an M2. So I'm going to go to, hello, Kingthorn. I'm going to go to this cooler M2 color. So I'm going to 190, 127 for my color. Thanks for the follow, Kingthorn. Okay, checking my numbers. Yes. So now, in order to figure out the delta in color that I want, I have to figure I'm going from 249 is my starting color, and I want to end at 127. And for the B part, I'm doing these backwards, sorry about that. And then for the G part, I want 190. So this is figuring out, if I'm doing this in n steps, how many color bits do I need to move over to get my gradient to be a nice smooth gradient. Hello, Mosborg. So let me get my animation to the top. Thank you for the follow, Starforge Ape. That is just a silly, silly name that implies so much good. Oh, I'm redeclaring variables. So the language I'm using is called processing. It's basically Java with a really nice framework for doing animations, data visualizations. Oh, I'm sorry, King's Throne. You can see I keep doing this when I'm trying to read chat. I probably should be wearing glasses. Okay, this whole getting older thing, man, I don't like it. Oh man, I don't know what I did, but it totally did not work. I need to be doing the other side of the planet, so I want to do plus n minus I to do the other side. Let's see what happens. That did not, no, that was wrong. Let's think this through again. So it turns out mathing while talking is not a skill I have. So planet radius is what radius I want to be at. Planet X defines my center. Planet Y also defines my center. Oh, so this is adjusting the X radius I draw to. This is adjusting the Y radius I draw to. And this is adjusting where it starts and where it finishes. So what I want it to do is start at the angle pi divided by 2 and then go to pi? We will find out. I did half of it. I want to go to 2 pi? I think I actually want to go to 3/4 pi or something like that. No, that was no. You can see, first of all, I have the colors completely wrong. But you can see it's wrapping all the way down around. So I went one too far. So I need to go to 3/2 pi. That also wasn't it. Why am I such a failure? It's not pi. It's not 3/2 pi. Why isn't it pi? This is where you are free to laugh at me. This is a mutant version of Java. Thank you, Koi Pond, for the follow. And I'm completely forgetting. So if my bottom point is pi over 2, this is pi. So I'm going from 1/2 pi to pi. Then I thought the top would be 3/2 pi. I'm wondering if I'm having a float issue. I don't think it's a float issue. Times pi times. So pi times 3/2. I'm about to pull up the document. Okay, I thought I did that already. I lied. Noel. A halibut? Really? You need a shrubbery. You need a shrubbery now. Okay, so I have it doing the shading correctly on both sides. I don't have the colors right. I did something truly wrong with the colors. Just for the fun of it, I'm going to go to 0 on both of these to see what happens. Okay, so that just overwhelms it, which makes sense. Let's go. So before I went to 215, let me pull up my color table again. So I'm trying to figure out what colors I was using before. So I had 255, 249, 249. So that is this. Oh, this is the bright outer color. So start with the outer color. Okay, that's what I did wrong. So when I mathed this, what I wanted was my starting color is, I clearly didn't like myself enough, so I didn't, is the gradient color. I clearly didn't like myself enough because I didn't write enough comments to know what I had done. So what I want is this 255, 215, 215, 174. That should be the central color of my object. Now what I want is to go to something even colder. So now I'm going to go to the M2. So this is 190. And this is math. It's hard. 127. So 190, 127. So now for my G's, what I actually want to do is 215 minus, okay, so before it was 249 minus 215. So here I want to do 190 minus 215. Here I want to do 127 minus 174. So this will give me a negative number, which should change my color in the correct direction. Thanks, Kinetic Pause, for the follow. Okay, so let's go ahead and run this. And I don't see a difference at all. This is where I go, what happened? And I do a print n plus a space and try and figure out, actually I want to print del G and a space plus del B plus a space. And I'm not going to bother with a carriage return or anything. I'm just going to run this. So it's doing There's no negative signs on that. And there's no spaces getting printed. There is something very wrong going on. Okay, I'm going to add the negative signs manually and see if I can get this to work. There may be something in the logic that is just noping hard. It's okay to randomly try things to see what does and doesn't work. Being an experimentalist is part of programming. This is why we test. So, yeah, Mosborg, this is one of the things that deeply bothers me with how we teach kids with coloring books. So here's the thing. You have a little kid. When you ask them to draw something cold, you have them note it in blue. When we look at weather maps, cold is blue. Cold is hot. If you have a blue hot stove, it will melt your pots. If you have a red hot stove, it will cook your food. Yes, you hit one of my pet peeves. So I want to take 215 and I want to subtract, and I want to take 214 and I want to subtract. And I'm so confused. I am so very confused. Okay, so because my code has me confused and I don't know what I screwed up, I'm going to just manually set this color to god-awful red and see if the code that isn't working is the part that draws things. Semicolons matter. Or how I'm calculating the color. Okay, so I managed to draw a truly horribly colored half of the planet. So now I'm going to put in oh, I know what I did. So I'm going to put in the planet R, because the R color never changes. And here's where I made my mistake. My starting color isn't what it used to be. So my starting color should be 190, 127. It should be dark. So here this should show the dark color I'm aiming for. So you can see that's darker than the center. Now with this, I want to, because I'm going to a higher number on the delta G. I want to add my delta G with my 127. Where did 127? So with my 127, I want to go to 174. So there's my delta B. And I have to multiply both of these by I, which is just how many times I've been doing this. And I am sad. So these are both floats. These are not floats. So one of the things that I absolutely hate about Java is it's super tightly a float is a float is a float. An integer is an integer is an integer. If you multiply an integer by a float, you get an integer. My brain just wants it to like treat numbers like floats until I tell you they're ints. And now I have it going in the opposite direction of what I wanted. So what I needed to do was start with 215 minus delta G. 174 minus delta B. There. Now you can't see it as well as I'd like, so let me go ahead and find where I defined my planet radius. So this should be 0.08 of my star size. There, it's quite sad. I'm going to fake the size. I'm going to scale up the sizes on this. So let's make our image field bigger, and everything should scale with that. There. So I'm going to scale this even more until I'm less unhappy with the size of my planet. And this is the actual scale in radius between these two objects. And since we're focusing on the planet, I'm going to scale this up one more time. Whoa, okay, that may have been overkill. I don't even know what you can see right now. Okay, you can see our little planet. Floats can totally be negative in Java. So the weird green color that you found, the smargin, is what I'm using for the pointy stick. So let me redraw the pointy stick. So the pointy stick is showing us which side of the planet is facing the star. And we're going to keep track of that little stick to help us understand the shading. What I'm trying to figure out is where I drew the little stick. It's this line right here. So what I'm going to do is add a comment, because I didn't like myself when I did this before. Draw a stick. Okay. And I'm going to draw the stick at 0.1 width. I don't know if this is wise, but this is what I'm going to try and do. Okay, it has Pinocchio's nose. That's a thing. I'm going to make it a little bit smaller because my Pinocchio planet is a little bit disturbing. I commented the stick, Paranor. I commented the stick. Okay. Now, that dark color still isn't as dark as I'd like. So I'm going to bring back up our color codes. Thank you, Oust, for the follow. So I'm just going to keep making the other side colder and colder and colder until I like the other side. So this is the bright side. This is the dark side. So I was 190. Let's go to 187, 123. I need to change one of these numbers. The 215 should go to 187. The 174 should go to 123. Let's see how that looks. Okay, that's a little bit stronger. I can play with this more later. Yes, this is a stick. My planet is clearly a liar. Now, what I want to figure out how to do next is to draw the planet on the other side in a sensible way. So what I want to be able to do first is I'm just going to move the whole planet en masse to the other side. Once I have the planet moving to the other side and then moving back, and I'm going to initially do this linearly, once I have the planet moving back and forth across the screen, then I can start to systematically figure out, okay, if my planet is actually orbiting, how does the size of it appear to change? How does the coloration appear to change? And I'm going to use the green stick to point where the planet thinks the sun is at all moments. And we're going to do one step at a time, figure out how to get all of this to step through. So I'm going to add above all of this are goals. So here we're drawing the sun, meh. That isn't the part that I'm worried about. The sun's just going to get redrawn every single time. And the reason it gets redrawn every single time is when there's a planet smushed on top of it that moves the next time. If I don't redraw the sun, it essentially stamps the planet across the surface of the sun and looks silly. What I'm inside of right now is a loop that is constantly redrawing my screen at 10 frames a second, I think. So I'm going to add in comments to describe what are the kinds of things that I need to do. So I'm only going to be able to code so many of these at a time. But our ultimate goal is, first, let's make the planet orbit. Let me add the word planet. Planet should orbit. The stick should point at star. Shading should be correct. So we'll do each of these things one step at a time. Now here's where it starts to get interesting. I'm going to also adjust size of planet with perspective. Assume 10 orbital diameters away. And here's where it gets really interesting. Planet is losing mass due to solar wind. So this planet is having material get blown off of it by the wind coming off of our giant star. Now, this means that I need to, add solar wind. And the physics isn't going to be 100% accurate because that would require me to either spend way more hours coding this than I have time, or to have a license for IDL, which is expensive software that I don't need to purchase just to do stuff like this. So I'm going to add in the physics, but there's going to be approximations involved because what I'm trying to do is explain everything that's going on so that it's understandable and communicating the science rather than so that it's 100% accurate and requires a supercomputer. So once I add the solar wind, I need to add a planetary tail. One thing you may not know is if you pull up the right images from Solar Dynamic Orbiter, you can see that Mercury actually has a tail of particles streaming off of it. And this is just because the sunlight is constantly ionizing things and knocking things off the surface of the sun. And as this happens, those particles escape Mercury's gravity and they're they're a tail, just like a comet tail, but more interesting in composition. So it's possible for more than just comets to have tails. Um, okay, so Fenmil has a question. So any BOE guess on the force pressure, back of envelope guess on the force pressure of the solar wind? I can look up the sun's pressure. I knew this once. I passed that test. I forgot the number. Sun's wind pressure mercury. Hopefully will get me there. These kinds of specific numbers I don't always remember. Sorry, looking at my other screen. It is, according to Physics of Solar System Plasmas, a 2004 paper by Thomas Cravens. It's 1.3 times 10 to the negative 8 pascals. So it's what we would call a vacuum on Earth. But the real killer is there's high energy particles also coming off of the sun. These are high energy electrons. And when they hit the surface, there's a transfer of momentum from these higher mass, high energy particles. That transfer of energy shoots ions off of Mercury, and then the solar wind is able to push them away. Fenmil, sometimes you just have to memorize things for a short period of time. I'm really good at memorizing concepts and like they stick. I'm really, really bad at remembering specific nouns and specific numbers. Even though I grew up in New England, I really struggled to remember the dates from the Revolutionary War. And Paul Revere ended his ride in the town I grew up in. Some things just don't stick in my head. Okay, so the planet is losing mass. Now, in addition to losing mass, for the planet, we also have tidal waves. So this is tidal, let me use a different, gravity creates waves on surface of star that follow planet. So this is what we're looking to go through. It's kind of cool. Now, we're going to do this a little bit at a time. So let me see what matters. Hey, Big J, welcome. Big J, can you blather at everyone about what all we're doing with CosmoQuest? Big J is actually one of our employees. This stream is actually part of my day job. I'm principal investigator of a project called CosmoQuest, and we have a variety of different funding sources, including your bits and subscriptions here on Twitch that allow us to do science education, and work on developing software that will help you better understand astronomy and better do astronomy. And Big J periodically shows up on this stream as well, and the rest of the time he works on the other side of the wall from me, or occasionally in the same room because I tend to wander. Okay, so the first thing that I want to do is figure out where I set the planet X and Y. Here's where I set them. So I'm going to grab that information, find where I just put all my comments. There it is. Planet should orbit. So I'm moving that code up here. The radius, I'll reset underneath the next comment. So what I'm going to do is I'm going to copy that and stick it under here. And now delete this. Now I want to change this comment, set planet location. And how best do I want to do this? So here is my initial position. Start at blurg. Now I want it to go to the exact opposite side. So planet has no inclination. So I'm only going to be changing X. That did not go as planned. Does not change. Now, if I had it changing in Y, that would be showing that it was on an inclined orbit. I don't feel like mathing that hard, so I'm going to be lazy and just have it orbit in the X plane of our particular thing. Okay, so here I now want to figure out a position for X. Should move to symmetrical on other side. So goal, go to 0.1 times width. So I want to go to 0.9 times width. In N. So I need to decide how many steps I want to do this in. So I'm going to initially do this in 100 steps, and then I'm going to, once we get that working, I will fill it in so it's continuous motion. So initially it's just going to go bounce, 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 bounce all the way around. So planet should orbit. I'm actually going to change the ordering of some of these. So I'm going to do this next because I'm going to do the low-hanging fruit first. And I'll fix those numbers later. Okay, so for I equals 0, I less than 100, and I'll turn this into a mathy thing later. Null, huh? What do you mean 18,264 degrees? You have confused me, Noel. Angular diameter from 10 orbital. Oh, I see what you're talking about. Okay. So what I'm interested in, Noel, is figuring out how much the planet changes in size. So I'm looking at the percent difference as it goes from its middle point to its nearest point to its furthest point. So we'll get there. It's a slightly angrier calculation. So I plus plus. Actually, so that will get me going in one direction. I'm going to do both directions in 2 different loops, and the reason I'm doing this, doing it in 2 different loops, is so that I can get the size behaving in a sensible manner. Okay. For I equals 0, I less than 100, I plus plus, take the planet radius equals the old planet radius, not planet radius, what am I doing? Planet x equals the old planet x no, that's not what I want to do. So I'm going from 0.1 times the width to 0.9 times the width. That is a step of 0.8. 0.8 divided by 100 times width is where I want to end up. So, and then this is times I. So what it's doing is it's figuring out how big each step is. Let me pull this out and make it make more sense. Orbital step. Equals 0.9 minus 0.1, and I'll eventually go through and clean up my code and add variable names for a lot of these things. So that's the total distance that I want to go. I want to do that total distance in 100 steps. So I'm just going to divide that number by 100, and I'm going to make this a float. Okay. Now my position at any given time is going to be the orbit, it's going to be the I'm having mouse issues. Orbital step times the width. And I'm starting at 0.1 times width. So you can already start to see where I'm going to want to add more variables eventually when I optimize this. So let's see. No, I got noped by that. Why did I get noped? Cannot convert from float to int. So orbital step, I have to put all of this inside the command int. That's fair. I'm going to get yelled at for this particular kind of mistake a lot. It didn't move, ever. Why did you not move? That makes me sad. Let me make sure I'm not resetting X anywhere. I am not. No, that's awesome. If you can do the maths, do the maths. I will never stop anyone from doing maths. So I'm going to look for all the places I define and use planet X. So find, so that's where I declare it. Then, where did all my code just go? Oh, I put it in the wrong place. That would be part of why I was confusing myself. Let's move this where it belongs. Okay, so goal is to go from 0.9 times width. Goal is to go to 0.9 times width in 100 steps. So orbital step is that. Oh, I never multiplied by I. So I never told it to actually move. Let's see what that does to me. That moved it to the other side. Oops. Let me make this a float. So what this should do is create a distance that this sucker moves each time. And I suspect that I'm continuing to have float to int issues. I have now floated all the things. That did not help matters. Okay, I'm going to make sure that it's just moving by simply saying position X is equal to 100 times I, and it should move. Oh, I know the problem. I know exactly the problem. Someone just did something and I don't know what they did. Thank you, Strodow, for the follow. Okay, so I'm being stupid. I do this sometimes. What I'm trying to do is move the planet in one frame. That's dumb. So planet should orbit one step per frame, which means I need to keep track of outside this loop how many steps there are to go. So I'm going to come up here and I'm going to add an integer, int step, and now down here, and I'm going to give it an initial value of 0. So step starts at 0. Now what I'm going to do to get my planet moving is, okay, someone had a question. What is the ID? It's processing. So this is a, framework's not quite the right word, but it's the best I've got. It's a framework built around Java that allows you to do animations with a lot of really nice built-in functionality. So the way this works is I have all my global variables just kind of living up here. Then I set up how big I want my canvas, which is the thing I'm drawing on, to be. So if I suddenly make my canvas tiny, I have an adorable little system. So I have everything set up currently to scale with size. And I'm going to stick with this adorable one while I'm trying. That's actually a little too tiny. I'm going to shrink things back down for a little while I'm working on sorting orbits. So it sets up your canvas to you, and then I have certain things that I'm just going to reuse all the time. One of those that's never going to change is the size of my sun in the solar system. So here's my solar system. Star, planet. I currently have this set to 10 frames a second. Now it gives me setup function for free, and the other thing it gives me for free is my draw function. So here I'm coming in and I'm setting the background to be Cosmic Latte, which is the aggregate color of all the light in the universe. So if you added together how much light there is in the infrared, how much light there is in the UV, added together all of this and created a light a plot of the amount of light per wavelength and tried to figure out how you would see it. Cosmic Latte is the color they came up with. It's beige. It's beige. I didn't exactly want beige space, so I lowered the intensity by just putting a layer of black on top of it and making the black fairly thin. The next thing I did was I drew my star, which is Kelt B. It's an actual star. This is work that I think was done by Scott Gowdy. And I looked up how big it is. I looked up what color it is using black body, and I drew it. I then wanted to add limb darkening, which is this blue, darker, cooler region you see around it. This is just the code to do that. Now I'm going through trying to figure out how to get my stupid planet to move. Now, where I screwed up before was I did a loop that was looping during one frame. That doesn't work. So what I want to do is add the word frames here to remind myself what units to work in. And I'm going to do a loop that is, so it's automatically looping. So what I want to do is planet X position is equal to 0.9 minus 0.1. So this is, it's going to go from the leftmost edge. So it's going to go from 10% inside of the left to 10% inside of the right times width. And I want to have it do this in 100 steps. So I'm going to calculate this step outside of all of this. So up here where I'm setting up the size of the sun, I'm also going to set up orbit step. So that should work fine. Except I need to tell it it's an int. Let me define that up here. And the reason I'm declaring it up here is so that the variable is available in both the setup and the draw. Oh man, thank you, Noel, for the calculations. Can you get that? Can you figure that out as a percentage of size? So how many pixels across the star? So the star is, hold on, let me declare my variable and then go scrolling after that. Orbit step. And I'll move that calculation up here where it should have been to begin with. Because that doesn't need to be calculated every single time. It is the height of my canvas divided by 2. So assign it a value of 1. And we're not worried about the planet size change, the star's sun. We aren't worried about the star's size changing. We're worried about the planet's size changing. So you may need different information from me. Okay. So I have set my orbital step as that thing. So I'm now going to come down here and say planet X is equal to my old planet X value plus orbit step. Now, down at the end of all of this, I'm going to do some cleanup of variables. Clean up of variables. So one of the things I need to do is say if step less than 200, I need parentheses. If step less than 200, then what I want it to do is step plus plus, so increment. Then I want to do else. So the second it hits 200, I want it to get reset to 0. Now, what I'm doing up here to figure out the planet's position, so coming up here further, this is actually an if statement. So if step less than 100, I've been using other languages today. Then go to the right, else go to the left. Play. Why don't you like me? I don't know how I did that. Okay. Oh, sorry, Noel. Do you want to treat the planet and star as flat circles or spheres? So, what did I do wrong? Okay, let me answer Noel and then figure out what the heck I did wrong. So what I'm trying to do is they're spheres, but I'm only worried about their diameter since they're a perfect sphere, not an ellipse. So the sphere, the apparent diameter, as it gets closer appears to get bigger, and as it gets further away appears to get smaller. So I'm trying to figure out when the star is between, when the planet is between me and the star, how small does it appear compared to the size that it is when it's in the plane of the star, and then how much smaller would it appear if we could look through the star at it. Oh man. Okay, so where did I create this boondoggle of I feel like I lost my absolute last parenthesis that I really need, but it is saying no. So the one thing I hate about this IDE is it doesn't allow me to easily figure out where I lost parentheses. A good IDE instead of a good enough IDE will let me double click on the stupid parenthesis and it will show me its mate. So I have one that I can't account for. Those two match. I don't see any other parentheses in there. Then This matches with this. There's a missing bastard. So I still have one open. No parentheses there. Those two match. None there. Those two match. Okay, so now, yes, now you are going to let me do what I needed to do. Okay. We're not deviating from the center of the projection null. Everything will always appear to be a sphere. Cannot convert float to int. No, you can't, because you're lame that way. The language I spend most of my time working in, for better or worse, is PHP, which isn't tightly cast. Why aren't you moving? I want you to move. You're not moving. Okay, so what I'm going to do now is I'm going to tell it to print the value of step. And that number should increase. So the number's increasing. Stop. Stop it. Stop. Okay, so I know that that number is increasing. Now I'm going to change. I'm going to see what planet X is. Oh! I didn't calculate orbit step anywhere. That would be the problem. That would be the problem. So orbit step, I think I just set up here and I need to multiply it. Yep, I need to multiply that by the number of steps. Times step. That should have worked the way it was actually. So if I'm adding a step to it every time, it's taking the old value, incrementing the old value. Yeah, let's print planet X. I understand you can math to distortion, but so it seems to be of the opinion that planet X is 53 no matter what. So, because I keep resetting this stupid value. Okay, so I just need to multiply this by the number of steps times step. Or, instead of that, let's move my initial setting up here. This should work. Yes! I made it move! I made Pinocchio move! It's gonna get to the other side and it's gonna reverse directions. It didn't quite get where it was supposed to get. But it's moving. I wonder why it's not getting quite as far as it should. It's kind of adorable. Yes, this can totally incorporate trigonometry. Okay, so I'm not going to try and figure out why it's not going as far to the right as it should. I think there's a less than or equals to issue somewhere. I'm not going to worry about that. It's going! It is indeed the world's most boring game of Pong. I have created that and I am proud of it. So I'm gonna stop here tonight. I have another stream to do on my personal channel. As I said, this is something I'm lucky enough to get to do for work, and I'm able to do this because you guys show up, you root, you learn, and science education is a large part of what we do here at CosmoQuest. Our project is run out of a nonprofit, the Astronomical Society of the Pacific, and everything we do is funded through donations, through, well, federal grants, which you all know how science funding's going, and stuff like that. Um, I'm going to copy the numbers that Noel just gave me because I'm going to want those numbers later. So if you like what you see, a follow is free and will get you notified of future presentations. If you'd like to help sustain all of our efforts, one bit, well, from enough people, even one bit adds up. So thank you for everything you do. Thank you for showing up. Thank you for asking questions. Um, I'm going to keep doing this until I get this to work. McLemare, thank you so much for the follow. So next up on the CosmoQuest X channel here on Twitch is tomorrow is Wednesday. I'm going to be doing at noon local a 15-minute-ish update on everything that's new in astronomy and space science. This is what we call the Daily Space. It's a play on Superman's The Daily Planet. I am not Lois Lane, but at least for the astronomy beat, I'm going to try. And the actress who played Lois Lane passed away today, so raise a glass. Anyways, I will be on this channel tomorrow for 15 minutes going over the daily news. So show up, get your head filled with science. We are here to put science in your head. So wherever you are in the world, I'm going to spend just one moment trying to get my other channel up and running so that I can raid over to that. So if you want to hang out, see what's next, give me a minute to type. And there shall be a slightly panicky raid that takes place. You are about to see.